We're all familiar with the notion of graph paper in rectangular coordinates. So I've got some rectangular graph paper up here on the board, and that can be fairly useful if we're plotting points and doing graphs in rectangular coordinates. Certainly on proctored exams and quizzes, you are allowed to bring, as long as it's blank to begin with, your own rectangular graph paper if you want to be working with that. Okay. What I want to look at now is, do we have a similar thing with polar coordinates? Is there such a thing as polar graph paper? And there is. Okay. Now, if I think about what rectangular graph paper looks like, it's just a bunch of vertical lines and a bunch of horizontal lines. But that's just a graph of a bunch of constants. This vertical axis here is the line x equals 0. This vertical line next to it, that's the line x equals 1. Then we've got x equals 2. That's what those vertical lines are. And of course, over on the left side, we've got x equals -1 and -2, etc., etc. Okay. If I look at the horizontal lines, the x-axis is just the line y equals 0. And then this would be y equals 1, y equals 2, y equals -1, y equals -2. So basically, if I'm plotting a point, and I know that the coordinates of that point are 1, 2, that's going to be at the intersection of the vertical line where x is 1 and the horizontal line where y is 2. So having these constant lines drawn in help me to locate those points. So if we're working in polar coordinates, it makes sense that rather than having a bunch of vertical and horizontal lines, what we're going to have is a bunch of constant curves, r being constant and theta being constant. Now, let's start out with our thetas. Okay. Now, I've got here my general frame of reference with my overlapping system. So here's the x and the y axis with the pole corresponding to the origin and the polar axis corresponding to the positive x-axis. These lines will actually be part of my polar graph paper because they are constant theta curves. If theta is equal to 0, the ray that corresponds to that is the polar axis, right? But that is just telling me that this is the positive direction. Remember, r is allowed to be negative. So points over here on the negative x-axis would be points that could have theta being 0. They would just be points with a negative r value. Okay? So while I often draw in a ray for a particular theta value, you often see me draw in the other half of that line because that's the part of the line that would correspond to negative r values. So if theta is constant, I'm just getting a line. Okay, so this line would be theta equals 0. Notice I get the same line if I look at theta equals pi. It's just that then the left side is the positive half and the right side would be the negative half. Okay, this vertical line, that would correspond to theta equaling pi over 2. There, the top part would be the positive part and the bottom part would be the negative part. Of course, I get the same line if I graph theta equals 3 pi over 2. It's just that then the positive part is the negative part, etc., etc. So if I looked at theta equals pi over 6, okay, well, that would give me the positive part. I'm not going to bother drawing the arrow on the end, but it goes on forever and ever and ever. Okay. The negative part of that would look like so. So if theta is constant, I'm just getting a line through the origin, and it's the line that makes that angle with the positive x-axis. If I also draw in theta equals pi over 4, that's going to be this line right here. Theta equals pi over 3 would be this line right here. You may have noticed, by the way, we always are measuring our angles in radians, not in degrees when we're in polar coordinates. Okay. All right. Now I can do the same thing over here. I'm basically drawing in the lines that correspond to theta values with a reference angle of pi over 6, pi over 4, or pi over 3. So I get these lines like so. And then if I were plotting something that had an angle of pi over 3, I'd say, okay, this is pi over 6, pi over 4, pi over 3. So it's going to be somewhere on this line. And then to figure out where, I need to know the r value. So what does r constant look like? Okay. Well, if I look at r equals 0, that's just the pole. That's this point right there, because the distance from the pole has to equal 0. Okay. If I look at r equals 1, that's the set of all points that are 1 unit from the pole. Okay. So that's a positive distance. We would just find an angle, but the positive direction could be defined by any angle. So if r is 1, we're just saying we're 1 unit from the pole, 1 unit from the origin. That's the unit circle. Kind of cool. What does r equal negative 1 look like? It's exactly the same circle. Plus and minus 1 look the same. What would happen is that this point right here, if I'm saying the r value is 1, I would have to associate that with an angle that was coterminal with 0. If I wanted to view this point as having an r value of negative 1, then I would have to associate that with an angle that was coterminal with pi. Okay. But if r is plus or minus a number, that's always going to give me a circle whose radius is just the absolute value of that. So if r was plus or minus 2, I'd get a circle of radius 2. So my polar graph paper kind of looks like a spider web. It's kind of neat. But now notice, if I wanted to plot 3 pi over 4, I can do that. Okay. The 3 pi over 4 tells me it's going to be somewhere on this line, okay, where this is the positive direction. Okay. The radius is 2, it's going to be somewhere on this circle. So it's the intersection of the line corresponding to theta equaling 3 pi over 4 and the circle corresponding to r equals 2. Kind of neat. I like it. Okay. Now, on proctored exams and quizzes, I'm not going to allow you to come in with pre-printed polar graph paper because I don't want anybody to have an advantage, and you can easily go online and print out polar graph paper, but I realize not everybody has easy access to a printer. Okay. So I have no problem with you on an exam generating your own polar graph paper if you want to, but you've got to generate that during the exam. You can't bring it with you to the exam. It's just too difficult for me if you've got handwriting on a paper when you hold it up to show me it's blank. It's too hard for me to distinguish that, no, that was okay because it's polar graph paper. So if you're going to make polar graph paper, you're more than welcome to, but you got to do it yourself and you got to do it during the proctored exam. I don't think it's actually necessary to have polar graph paper because I can always just draw in the ray for the angle that I'm working with at the time. This tends to be more useful sometimes if you're drawing curves, graphs of equations in polar coordinates. And we're not really going to be spending a lot of time doing that this semester. That's in 7.2, which we're not going to cover. We're just going to get a basic introduction to things. But I did want to show you this notion of polar graph paper, and it kind of makes us reassess what we mean by graph paper. Graph paper is just a bunch of constant curves. In rectangular coordinates, those happen to all be horizontal or vertical lines. In polar coordinates, that's any line through the origin and any circle centered at the origin. It's kind of cool. Let's just plot one more point. Let's plot -1, 5 pi over 6. Okay. So 5 pi over 6, that's going to correspond to this line right here. 5 pi over 6 would be making an angle of pi over 6 with the negative x-axis here. Okay, so this is the positive direction. Since r is negative, we're going to follow that line in the negative direction until we hit the circle of radius 1. Okay, and We wouldn't say this is a circle of radius -1. The radius of a circle by definition is a positive number, but this is the constant curve r equals -1. Okay.